In this lecture, we're going to continue our discussion of arrays with NumPy. So as we previously discussed, NumPy arrays allow us to construct code that is very readable and simple to write, that is nevertheless massively more performant than the kind of code that we would write using our base Python tools. So what we're going to do in the next couple of lectures is discuss how to create and modify and retrieve information from arrays. In this lecture, we're going to focus on creating arrays. Okay, so as we've already seen, there's a very simple way to create arrays in NumPy, and that is using the array function called onAList. So let's see it in action. First, as always, I need to import NumPy as NP. So now I can call it using just the NP prefix. And now I'll define a simple list of numbers, L equals 1, 2, 3, 4. And then I'll create an array by calling np.array on L. And then if I take a look at the result, here's A. And I see, indeed, I've successfully constructed an array with 4 elements, 1, 2, 3, and 4. So this is great. Very handy for small manual arrays. However, we often want to construct very large arrays. And for this, just creating lists and turning them into arrays is often not the best approach. So NumPy also offers functions for building a large number of arrays that we might need to use very frequently. So here are a few examples. So I'll just make n equals 3 here to tell the size of the arrays that I want to create. Let's create an array of zeros. So here's np.zeros creates an array of zeros of the specified length. Handy. Okay. Similarly, np.ones creates an array of the specified length. I'm filling it with ones. These are both filling with floats. So this is 0.0 and 1.0 respectively. You can tell from the little dots after the zeros and the ones here. So NumPy loves floats. It will usually default to floats for many of its functions. Okay, another very common task is to generate random numbers. As you've seen in this course already, I love random numbers. So let's really find the easiest way to generate lots of random numbers is to use np.random.rand. Similarly, n here tells me the length of the array that I'm going to generate. And I now have 3 random numbers between 0 and 1. 3 random numbers between 0 and 1. Okay. NumPy also gives us an array version of the range function that we've come to know and love. So if I do np.arange, so the a here is for array range, np.arange of n. This looks a lot like the range function in Python. It goes from, so we did np.arange of 3. Our result goes from 0 to 2. So that's similar to the range function in base Python. Unlike the range function in base Python, here we have a NumPy array of integers from 0 to 2, including 1. Okay, finally, another very handy function, especially when plotting mathematical functions, is linspace. So np.linspace 0, 1, and n will give me evenly spaced points between 0 and 1. So this is my lower bound, this is my upper bound, n tells me how many points to create. So that's 3 evenly spaced points between 0 and 1 inclusive. I got 0, 0.5, and 1. Of course, if I ratchet up n, then I'll get a lot more evenly spaced points. So in this case, I am counting by 100. So I have 0, 0.01, 0.02, and so on. Okay, so those are a few of the most common ways to make one-dimensional arrays in Python. So one-dimensional arrays are a lot like lists of numbers in many respects. However, one of the great things about NumPy is that we can operate not just on one-dimensional arrays, but actually on multi-dimensional arrays. So arrays with more than one dimension. So what does that mean? Well, here's an example. Let's start by checking out the shape of the 1D arrays we've been working on. So let's do np.ones. So here's, so in this case, A is just an array of 3 ones. And if I check for the shape attribute of A, so a.shape tells me the shape of A. And what I get out here is kind of interesting. It looks sort of like a tuple, although it's not quite that. And it says 3, comma, and then nothing within these parentheses here. What that says is that A has a single dimension of length 3. A single dimension of length 3. So A has just one dimension, and along that dimension, there are 3 items. Okay, in order to understand what that is and what that means, it's easier to contrast. So let's do a nice little contrast here. I'm going to create a capital A. Capital A equals np.ones. And we're going to call it now, not with just n, but with a tuple, n comma n, in my call to A, or in my call to np.ones. And what I get out looks pretty different, right? So this is, it looks like a square array of numbers, or a matrix, if you're familiar with matrices. So here I have an array that has rows and columns. Another way of thinking about this is that it's not dissimilar from the grids that we've previously made using lists and list comprehensions in several discussion activities. So if we now check if we now check what a.shape is, so a.shape here is now 3, 3. So that says that A has 2 dimensions. There's effectively a dimension corresponding to rows and a dimension corresponding to columns. And what we've learned is that A has 2 dimensions, and along each dimension, there are 3 elements. Okay, so 3 entries along each dimension. So just again, to get a visual on that, we can print out here and we can say, oh yeah, each row of A has 3 items and each column of A has 3 items. Okay, so this makes sense so far. We can create multidimensional arrays. I've shown you one way to do this using np.ones, but there are many possibilities. And we can also query the shape of arrays to see how many dimensions they have and how large those dimensions are. Now, NumPy does not even restrict us to 2-dimensional arrays. We can create arrays of arbitrary numbers of dimensions. So for example, A equals np.ones, and now I'm going to give it another tuple, n comma n comma n. So this is a 3-dimensional array, a 3 by 3 by 3 array. If I now check on A, I'll see that I indeed have essentially 3 copies of the 2-dimensional array that I had previously. I can also check for the shape. So here I check a.shape, and I see indeed I have 3 dimensions and 3 items along each dimension. Each dimension has length 3. Okay, so we can create arrays of arbitrary numbers of dimensions. In this course, we won't really do much with arrays of dimensions larger than 2. So we can focus on dimension 2 arrays in this course. Next, I'd like to show a way to change the shapes of arrays. So one simple way to construct arrays is by creating an array of dimension 1 and then changing it into an array of dimension 2. So here's an example. A equals np.arange of 15, and now I'll check on A, and what I have are the numbers 0 through 14, represented as a 1-dimensional array. Okay, fine. What I can do is reshape little a, so I can create big A by calling the reshape method of NumPy arrays, a.reshape. And now let's go ahead and let's make big A an array with 3 rows and 5 columns. Okay, if I now check on what A is, big A, I'll see, okay, I have an array now of 3 rows and 5 columns. Across the top, I have 0 through 4. Then I bump down to the next row, I have 5 through 9. Then I bump down to the following row and I have 10 through 14. So I've taken my data and I've restructured it into a different format. I could also reverse the arguments. So for example, I could instead do this. B equals a.reshape. Let's do 5, 3 instead of 3, 5. And then I'll check on B. So now B looks kind of similar, but the dimensions are transposed. So across the top, I have 0, 1, and 2. Next row 3 through 5, next row 6 through 8, and so on. So I can reshape my arrays provided that I have the right number of entries to match the dimensions and lengths that I've specified. You can also undo reshape pretty easily. So let's undo the reshape of A, for example. I can just do little a equals a.reshape. I can actually just say, hey, I want 1 dimension of length 15 again. And then I'm back where I started. So I took little a, which had 1 dimension of length 15. I reshaped it into big A that had 1 dimension of length 3 and 1 dimension of length 5. And then I reshaped it back into a single dimension of length 15. So you can play a lot of games here by creating arrays and then reshaping them to create new arrays. Now, so far, we've really only created arrays and then sort of messed with their shape a little bit. In the next couple lectures, we're going to learn how to modify arrays, and we're also going to study how to aggregate arrays and actually crunch numbers using NumPy. So stay tuned.